Was the canyon jump realistic? So this is AJ. AJ and Bear and the Russian guy, I forget his name, are in the Armadillo in the crashed shuttle, and they need to get over to Harry. There's a canyon in the way. They decide to jump it. Is this realistic?
We're jumping over this canyon.
Here we go. Here we go.
I mean, clever solution.
Oh.
Except for this bad.
Here we go. Going up. Man, their equipment.
We're about a mile off the asteroid! Just a second, the fuel line is iced up! Getting higher, man!
Oh, we're spinning.
Hey!
Hey.
Oh my gosh, so dangerous. Improbable.
What a cool sequence. So the question is, so they launch, into the, like this.
Okay.
Is this realistic?
Maybe.
So, okay, so we're assuming that we're on Ceres. Okay, the reason why we're assuming on Ceres is because in the movie they say it's the size of Texas. The asteroid is the size of Texas, which we're going to roll with here.
Okay, let's roll with it.
And the important thing here is that the equatorial surface gravity is 0.03 g.
Okay.
Or 0.284 meters per second squared. So let's figure out how far they actually can fly under these conditions.
We're going to do a projectile motion?
Projectile motion, let's do it.
Okay, let's do
So
it.
I think a reasonable vehicle speed would be 25 miles an hour. I mean, these things aren't hot rods, right?
They're not hot rods. You want to go quickly, but not too fast. Okay, 25 miles per hour. That's all right.
Yeah. The G on Ceres is these numbers we just said. And then I think they launch at maybe, say, 30 degrees.
Sure.
But
yeah, they're not going to like 90 degrees and shoot up. Yeah,
Right.
sure. 30 degrees.
Okay. So the question is, how far would they fly?
Okay.
And so if we're going to use this equation from projectile motion, which is the
Kinematics.
final y position equals the initial y position plus the initial y speed times time minus 1/2 gravity times time squared.
Mm-hmm.
If we assume flat ground, meaning
Sure.
they land at the same height that they took off from, which I don't think is going to be true here, but it'll give us an estimate for how far they can actually fly.
Yeah. They're not like launching up a mountain or down into a valley. Like the ground levels are about the same, sure.
Yeah. So that means we can set the final y position to the initial y position. So we get 0 equals initial y speed times time minus
Okay.
1/2 g times time squared.
Okay.
We can cancel out a time. So we
True.
get this.
That's true, yeah.
Okay. And using that, we can solve for time.
So you're going to solve for how long they're in the air.
How long they're in the air. So that'd be
Okay.
2 times the initial y speed times g.
Yeah, that's good.
Then we can plug that into the x equation to figure out how far they flew.
Okay.
There's no atmospheric drag because I don't think there's an atmosphere. So their initial x speed when they take off times time will give us how far they flew.
Hmm.
So the final x position equals the initial x position plus initial x speed times time.
Okay.
Choose the launch point to be at 0 meters.
Sure, we can choose that.
So that means the final x position will be equal to the initial x speed times time.
Just how fast you're traveling for how long you're traveling.
And then we can plug this right here into this.
Mm-hmm. That's how long you're traveling. Yeah.
And then, okay, so this is the annoying part. The initial x speed is going to be the initial speed times cosine. of the
Cosine.
angle.
Yeah,
And
because if you're
initial-
launching up at an angle, the x speed is only the horizontal portion. Okay,
Yeah.
so that's a cosine.
And then the initial y speed is times the sine of the angle. And I see a mistake here. Got to fix it. Because its initial x speed is v times cosine. And the initial
Okay.
y speed is v times sine.
Yeah.
So this has got to be v. This has got to be initial speed squared.
Oh yeah, that's right.
Let's do it. Okay, here we go. Got to make the change. Okay, here we go. And then, okay. And same in the next
Propagate
thing.
it. Very good.
Propagate it through. Okay, 2 times cosine of sine is equal to sine 2 at the angle.
You did a trig identity. Okay, yeah.
So I used
that's
the
true.
trig identity. Was that a good
Trig.
idea? I don't know.
That's fine. No, that's
Okay.
fine. That's fine.
So the x final position is initial speed squared times sine 2 at the angle divided by g, which is the g of Ceres.
Yep.
So we plug in. We need this to be 11 meters squared. So if we multiply 335 meters times 11, what do we get?
You get 3,685.
Okay, meters. Okay, that changes our answer just a little bit. But I think, so if they were to launch at these on series with this G at 11 meters per second, which is 25 miles an hour at 30 degrees, which I think is reasonable, they would fly about 3.7 kilometers.
Okay.
Okay, interesting. So it's not very far, actually. I mean, longer than we calculated initially, but it's not very far. Because if the asteroid is the size of Texas, so here's Ceres, then, and this, the circumference of this is, do I have it here? No, I don't. But the diameter is 940 kilometers.
Mm-hmm.
So 3 kilometers, 3 to 4 kilometers on here is like beep, a little jump.
Mm.
Tiny little jump on the surface.
Gosh. That distance on that object, they might have already just been in line of sight with the other dig crew.
Right. Because what is it? AJ jumps the canyon and then he drives to go see Harry, which means if they're on an asteroid the size of Texas, and they said they were on opposite sides. So if they're on opposite sides, one is over here, one is over here.
Gosh.
They have to drive the whole circumference, half the circumference.
They must not mean opposite. They must mean like colloquialism opposite. Like not like,
Yeah.
I don't know.
I mean,
But let's go. They said opposite. Let's go with it.
Yeah.
Let's see
So
what they
here's
said.
the picture of AJ showing up at Harry's dig site. So the question is, will they make it? They need to travel. The distance to travel is the circumference divided by 2.
Okay.
So 2 pi times the radius is the circumference. We have the
Okay.
radius. Okay, we do some simplifying. Get rid of the 2. Plug in the radius with pi and divide by 2.
This is
We get-
good.
This is the distance they need to travel, about 1,500 kilometers.
Oh, so
that-
3.7K is kind of nothing.
Right.
It's
So
kind of
they need to travel this whole distance, and they did an initial jump, little boop.
Yep.
So
This is like a 12-day journey.
yeah. So speed required. If they want to get it in 1 hour, they need to go at 915 miles an hour. In 2 hours, 460 miles an hour. 4 hours, 230 miles an hour. In 8 hours, which is the entire mission time,
Yep.
is 115 miles an hour.
They ain't gonna
No
make
way.
it. They ain't gonna make
even
it
if,
at all.
Even if the vehicle is capable, no way, because the
No way.
terrain. At 25
Okay.
miles an hour, which is top speed of the vehicle, our estimate,
Yeah, reasonable.
distance divided by speed, 950 miles divided by 25 miles an hour, 37 hours. That's
37
multiples.
hours of straight driving, multiple missions
Yeah.
time. They're not gonna make it.
Not going to make it. So the conclusion must be that when they say opposite sides, they mean Harry's here, AJ's like here.
It's like they're almost touching.
Yeah. But I think we said earlier that maybe we need to abandon the idea that it's the size of Texas.
It's got to be a smaller.
It's got to be smaller so they can be on opposite sides, and traveling from one side to the next in rugged terrain is feasible.
Oh boy! If Truman is saying these colloquialisms and using metaphors and hyperbole, then what else is Truman saying?
Oh my gosh, yeah, Truman
Suspect.
is just suspicious, yeah.
The entire movie's questionable now.
And if it was much smaller, that would explain why it was such a late detection.
Harder to see.
Because if the Ceres is pretty big object, I think it might be easy to see. But if it's much smaller than the size of Texas, detection may happen much later.
Yep.
Meaning
It's just less surface area for the sunlight to reflect it towards Earth.
Yeah.
Smaller object, harder to see.
Mm-hmm. So maybe we need to abandon this idea that it's the size of Texas, because
I'm done.
that explains a lot. Truman, he's being a salesman, getting
Salesman,
that
that's how he
funding.
sold it. Yeah, he's like, it's as big as Texas. We gotta take it down. Like, oh, it's as big as Texas. We better just give you guys some money.
Money. And Truman's like, got it.
Truman got, yeah. Everyone else got played.